Hello everyone, this is Mr. McMillan. I'm here with the instructional video today. We're going to go over the property chart for quadrilaterals. So we're going to fill this in for each of the 6 types that we talked about. And then we are going to go over some example problems for finding angles and side lengths, specifically in parallelograms. And we'll be using the properties for those. We'll talk about trapezoids in the future, but parallelograms are the simpler or have more to do with it. So let's look at the first property here. It says exactly one pair of opposite sides is parallel. So when it says exactly one pair, that means it can't have more than one. So the only shapes or the only quadrilaterals that have exactly one pair of parallel sides is a trapezoid and an isosceles trapezoid. Number 2, it says exactly one pair of opposite sides is congruent. Same deal. Only one pair of them can be congruent, no more than that. Well, a trapezoid does not have any pair of congruent sides. All 4 sides are different lengths. But an isosceles trapezoid does have one pair of opposite congruent sides. And if you remember, those are the legs that are congruent. Okay, the parallelogram through the square all have more than one pair of congruent opposite sides. Number 3, both pairs of opposite sides are parallel. So isosceles and an isosceles trapezoid and an irregular trapezoid only have one pair. However, a parallelogram, rectangle, rhombus, and square all have 2 pairs of parallel sides. Number 4, both pairs of opposite sides are congruent. Similarly, a parallelogram, rectangle, rhombus, and square would have all of those. Number 5, all sides are congruent. So all sides being congruent, there are only 2 shapes or 2 types of quadrilaterals that have this property, and that would be the rhombus and the square. Okay, rhombus and square both have all 4 sides being congruent. Number 6, opposite angles are congruent. This is for the parallelogram onwards. Anytime you see a parallelogram, rectangle, rhombus, square, the opposite angles are congruent. Okay, so opposite angles are congruent for parallelogram, rectangle, rhombus, and square. Number 7, consecutive angles are supplementary. Now, when it talks about consecutive angles are supplementary, it's not talking about just 1 or 2 pairs of them. It's talking about all pairs of the consecutive angles. For instance, if we look at a trapezoid and an isosceles trapezoid, only the pairs of bases are. Okay, but that is not true for the parallelogram. All the consecutive angles in a parallelogram, rectangle, rhombus, and square are supplementary. And when we say consecutive angles, we're talking about ones that are connected by the sides, whereas the opposite angles are the angles that are not connected by the sides. So they're in the other corners. They're in opposite corners. Number 8, all angles are congruent. And it says there in parentheses, all angles are right angles. There's only 2 shapes that have or 2 quadrilaterals that have this property always, and that would be the rectangle and the square. A parallelogram and a rhombus might have them, but they would have to be rectangles or squares for that to be true. Number 9, the diagonals are congruent. Now, the way that I kind of try and remember this is for the congruent diagonals. If the shape has a tilt in it and doesn't have like a structure in it, then the diagonals cannot be congruent. So if it's tilted, that means one of the sides or two of the angles end up being closer to one another than the other two angles. And so the ones that would end up being congruent for the diagonals are an isosceles trapezoid, a rectangle, and a square. A parallelogram and a rhombus have a tilt in them, so that can't work. And a trapezoid, because of the way the sides are, none of the sides are equal. There's no way for the diagonals to be congruent. Number 10, the diagonals bisect each other. This is a property that's shared by every single parallelogram and type of parallelogram. So what that means is that the parallelogram or the diagonals of parallelograms, rectangles, rhombuses, and squares all have bisecting diagonals. Okay, they all have bisecting diagonals. And remember that bisecting diagonals means that each of the diagonals are split in half. They're split into two congruent parts. Number 11, the diagonals are perpendicular. The only way for a quadrilateral to have perpendicular diagonals is for them to have four congruent sides. So that means that the only two that have perpendicular diagonals of the ones we talked about are the rhombus and the square. Now a kite would also have perpendicular diagonals, but we don't need to know about a kite. And our last property here, number 12, the diagonals bisect opposite angles. Similarly, the only way that a diagonal can bisect the opposite angles is if all of the angles are the same, or sorry, all the sides are congruent. So a rhombus and a square would have diagonals that bisect the opposite angles. Okay. One important note is that all quadrilaterals have this property. The sum of the angles of any quadrilateral is 360. Okay, so that is important to know because there are some where it gives you one angle or it gives you three angles and it wants you to find the missing one. You would just take 360 and subtract the other three angles. Okay, so that's your property chart. Hopefully that gives you kind of a visualization of what's going on. And it's a good study tool to study all of these properties. A square pretty much has any property that you can think of for quadrilaterals other than one side being parallel. And it goes like that because the square is the most specific shape, then the rhombus is the second most specific, the rectangle is the third most specific, parallelogram fourth, isosceles fifth, and the trapezoid is the least specific shape. The only thing that you need for a trapezoid is that one pair of opposite sides is parallel. That's it. Okay, so let's look at some example problems here. And we're going to be covering the first two pages. I know there's a third page on there, but that's trapezoids. We ran out of time, so we're going to deal with that another day. So what it wants us to do is find the measurement indicated in each parallelogram, okay? And so there are two different things we could be looking for here. We could be looking for angles or we could be looking for sides. Okay, if we're looking for angles in a parallelogram, there are two different types of angles that we'll be looking at. The first one is the opposite angles. And from our property sheet we just ended up talking about, remember your opposite angles will always be congruent, which means that your opposite angles will always have the same measure. The other type of angle you can have is a consecutive angle. So the consecutive angles. These are the ones that have a side that connect them together, and those are supplementary. And remember, supplementary means they add to 180. They sum up to 180. So let's look at these. Number one, we're wanting to find this angle here. We're wanting to find angle F, and we're given angle D. So if we want to find the angle, we're given another angle, we need to determine whether those angles are opposite angles or consecutive angles. So let's look at this. For them to be consecutive, they have to be touching. They have to be sharing a side, okay? And so are F and D sharing a side in this case? Well, there is no line that goes directly from F to D, right? That would involve having to make a diagonal, and then it would still be non-consecutive because we're only concerned about the outside edge. So F and D aren't consecutive. However, the next thing we're looking for is whether they're opposite or not. And if you look here, do D and F touch? And are they in opposite corners? They don't touch, they're in opposite corners. So that means that angle F and angle D are opposite angles. So if they're opposite angles, that means angle F is congruent to angle D. And since angle F is congruent to angle D, that means that angle F would have to equal 78 degrees. So opposite angles are always congruent. So let's look at number two. We have angle A given to us. Angle A is 94. And we're wanting to find angle B. So again, we have to ask ourselves the question, are these opposite angles or are they consecutive angles? And the first thing I ask myself is if they're consecutive, because if they're not consecutive, they have to be the opposite. So are angles A and B connected by a side already? And if you look here, we can see that A and B are connected by that side of the parallelogram. So angles A and B are consecutive. And this means that these two angles are supplementary. And since they're supplementary, that means they add up to 180. So the measure of angle A plus the measure of angle B has to be equal to 180. Well, if those two angles together have to equal 180, then what that means is we can take 180 and subtract 94 to find the measure of angle B. And if we do that, we get that the measure of angle B is 86 degrees. So the important thing is determine if they're opposite angles or consecutive angles, and based on that, they're either congruent or supplementary. That's going to be important for setting up equations as well, because inevitably you will have to do that. All right, we're going to do 3 and 4 together, and then I want you to try numbers 5 through 8. So number 3, we're given that angle U is 115 degrees. And we're given that angle V is the one we want to find. So again, we ask ourselves, are these angles opposite or consecutive? Well, first thing I check is if they are attached by a side. And we can see that they are indeed attached by a side. V and U are attached by a side of the parallelogram. So V and U are consecutive, which means that the two angles add up to 180 degrees. So when we do that, we know that angle V has to equal 180 minus angle U, which is 115. So we get the measure of angle V is 65 degrees. And number four, we're given the angle E is 32, and we want to find angle F. So are these angles opposite or consecutive? Well, we see that these two angles are connected by this side here, so they are consecutive. And so that means that angle of F plus angle E must equal 180. So we're looking for F. So to find F, knowing that they have to add up to 180, we have to take 180 and subtract 32 degrees, which gives us 148 degrees for angle F. Okay. So what I want you to do, I want you to try numbers 5, 6, 7, and 8, and then check your answers and come back to the video. So let's look at number 5. Number 5, we have angle E, and we want to find angle C. So are angles E and C opposite, or are they consecutive? Well, they're not connected by a line, right? E is connected to B and D, but not C. So that means that angle E and angle C are opposite. So since they are opposite angles, that means that angle E is congruent to angle C. So what would the measure of angle C be? It would be 44 degrees. Number 6. Number 6, we have angle, or we want to find angle C, and we have angle A to be 60 degrees. Are these angles opposite, or are they consecutive? And if you look here, you can see that A and C are not connected directly, so they cannot be consecutive. So they are opposite. They are in opposite corners of the parallelogram. So that means that angle A is congruent to angle C, which means the measure of angle A, or sorry, the measure of angle C is equal to 60 degrees. Number 7, we're given angle V to be 110 degrees, and we want to find angle X. Now, angle V and angle X, are they opposite or are they consecutive? And we can see that they are opposite from one another. So that means that angle V must be congruent to angle X, which means that angle X has to equal 110 degrees as well. And then number 8, we want to find angle X, and we're given angle Y to be 85. So are these angles opposite or are they consecutive? And we see that angle X and angle Y are connected by a side. So angle X and Y are consecutive, which means that when we add their measures together, we have to get 180. So the measure of angle X has to be equal to 180 minus angle Y, which is 85. So we get the measure of angle X is 95 degrees. Okay, so for angles and parallelograms, you need to make sure if they're opposite, they need to be congruent. And if they're consecutive or adjacent to one another, they have to be supplementary. All right, now let's look at numbers 9 and 10 together. So number 9 trips a lot of people up just because it brings back a lot of information that we talked about in the first semester, okay, or in the first part of the year. And so what we need to do here is we have a parallelogram. So we know that VY and WX are parallel, and VW and YX are parallel. So if you notice here, we have a diagonal that's going through here. And we don't have the whole angle Y, and we don't want to find the whole angle W. We want to find this part of angle W. And we're given this part of angle Y. Now, if you remember, we could extend these out, these lines here. We could extend those out. And now we can look at these two angles here. YW becomes a transversal with two parallel lines. So if we look at this angle here and this angle here, they're both on the interior and they're on opposite sides of the transversal. So these were alternate interior angles. And if you remember, alternate interior angles are supposed to be congruent. So that means the measure of YWX must equal 72 degrees. All right, number 10. Now, number 10 is a bit of a tricky one. You'll notice that we still have the diagonals, and this is not just as simple as going, okay, they're consecutive, that means they add up to 180. They're opposite, that means that they are congruent. Okay, it's not that simple. Although we're going to be using those facts here to help us find the answer, you'll notice that you're given angle F to be 100 degrees, and you're given a part of G, not the whole thing, to be 36 degrees. Okay, so what the diagonal's done here is it split the angle G into two parts. Now, we don't know if those are equal because we don't know if this is a rhombus or, you know, whatever else. So we can't say, oh, well, those bisect, so we know the other part's 36. It may be, but we need to find that out. So we need to figure out the whole of what angle G should be equal to before we can find the part. So if we look at angle G and angle F, are they consecutive or are they opposite? Well, G and F are connected. So that means that the measure of angle G plus the measure of angle F must equal 180 degrees. Well, we know angle F is 100. So to find G, we take 180 and subtract 100, and we get 80 degrees. So angle G is 80 degrees. But that's not our answer, because that's the whole thing of angle G. These two are parts of angle G. So to do this, we need to use the whole angle. Remember, part plus part equals whole. And to find this missing part, we're going to have to take 80 and subtract the other part, which is 36. And so we get our missing angle to be 44 degrees. Okay, and you can add those together and add those up, and they will equal 180 degrees. All right. So what I want you to do, I want you to look at numbers 11 and 12, and I want you to try those on your own. So try those on your own, pause the video, come back and check it. Okay. So number 11, we see we have a diagonal that is splitting angle E, and we're given a part of angle E to be 38 degrees, and we're given angle D to be 93. So again, since we have a diagonal that has a part, we need to figure out what E is first. Well, angle D and angle E are connected by a line, so that means they're consecutive. So angle D plus angle E must equal 180 degrees, their measures. So I know angle D to be 93, so the measure of angle E must be equal to 180 minus 93. So the measure of angle E is equal to 87 degrees. So I know E is 87 degrees. But I'm not done yet, right? I have two parts, and I know one part is 38 and the whole thing is 87. So to find our missing part, we need to take the whole angle, which is 87, and subtract the part, which is 38. And when you do that, you get that your missing angle is 49 degrees. And then number 12. Number 12 is a similar situation. We have a diagonal that splits an angle. We're given that angle W is 78 degrees. and we want to find this part of angle V. So angle W and angle V, we have to find angle V first. They are connected by this side, so that means that they are supplementary. They're consecutive. So we know that the measure of angle V must equal 180 minus angle W, which is 78. So angle V is equal to 102. Well, we know the entire angle of V is 102, and we know one part is 63. So to find our missing part, we take the whole thing of 102 and subtract our part of 63 degrees. And when you do that, you get that your missing angle is 39 degrees. Okay. So that tells you just about everything you know regarding finding missing angles in parallelograms. Okay. Now let's look at number 13 and 14. Now, number 13 we're going to go together, and then you do number 14. Okay. So number 13, we have a parallelogram here, but this time instead of finding angles, we're looking for a side. Okay. And we see that our angle here is our side here is 19, and we're missing this side. Well, since these are parallelograms, you know that these two sides must be congruent. Remember, opposite sides are congruent. So that means that FG is congruent to EH. And what does the word congruent mean? Well, congruent means that they are the same. So if FG is 19, that means that EH must also equal 19. So then number 14, do that one on your own, come back and check it. So number 14, we see that VS is our missing side, and we want to find VS, and we're given UT to be 11. Well, UT is opposite of VS, so that means they're congruent. UT is 11, so that means VS must also be 11. So opposite sides on a parallelogram are congruent. Doesn't matter which parallelogram you're dealing with. Okay. All right. Number 15 through 20, we're going to be applying all of those properties we just did, but we're going to be solving for X here. Okay. So the important thing here is that you need to make sure that you set up your equation correctly on each one of these. So if something is supposed to be congruent, that means you set them equal to one another. If they're supposed to be supplementary, they sum to 180 degrees. So you would add them together and set them equal to 180. Okay. So what I want you to do, I want you to try 15 through 20 on your own. Try those out. Check your answers when you come back to the video, or you know, you can plug them back in, make sure, because if they're congruent, they should be the same. So if you don't get the same thing, then you know you got your wrong X value, and the same thing for supplementary. All right, let's look at number 15. Number 15, we're given line CB is 3x plus 2, and line DA is negative 3 plus 4x. And it says each figure is a parallelogram, so we know the opposite sides are congruent. So CB is congruent to DA. And since they're congruent, that means we can set them equal to one another. So we get 3x plus 2 equals negative 3 plus 4x. And then we solve for x. So I'm going to subtract 3x from both sides. And so we get 2 equals negative 3 plus x. I have a negative 3 here, so I need to add it to both sides. And so we get x is equal to 5 here. And if you plug that in, 3 times 5 is 15 plus 2 is 17. Negative 3 plus 4 times 5 would be negative 3 plus 20, which is also 17. So that checks out. Number 16. Number 16, we are given two angles here, and we're given angle S and angle Q. Now, since we're dealing with angles, we need to figure out whether they are opposite angles or consecutive angles. And in this case, we can see that S and Q are in opposite corners from one another. So that means that these are opposite angles and they should be congruent. So that means that we need to take these two and set them equal to one another. So 7x plus 12 is equal to 82. And then we solve for x. Subtract 12 from both sides, and we get 7x is equal to 70. Divide both sides by 7, and we get that x equals 10. If you plug that in, you get 7 times 10, which is 70, plus 12, which is indeed 82. Number 17. Again, we're dealing with angles here. We're given angle E and we're given angle F. And are these angles opposite or are they consecutive? And if you look here, we see that E and F are connected by this line here. So we know they are supplementary. So that means we need to take 110 and 34 plus x, or 34x plus 2, and add them together and set them equal to 180. So 110 plus 34x plus 2 equals 180. Left side, we can combine 110 and 2, which will give us 112. 34x is already by itself, so we need to subtract 112 from both sides. And if we take 180 and subtract 112, we get 68. Divide both sides by 34, and we get x equals 2. And if you plug that in, you will see that you'll get 68 for this angle here, which that works. All right, number 18. Number 18, we're dealing with sides, and these sides are indeed opposite from one another. So that means that SV would be congruent to TU. So we know that 4x minus 2 equals 10. Then we solve for x, add 2 to both sides, and you get 4x equals 12. Divide both sides by 4, and you get x equals 3. Number 19. Number 19, we're dealing with angles this time, and we're dealing with angles Q and P. So angles Q and P, are they opposite or are they consecutive? Well, they are connected by a line, which means they're consecutive, which means they're supplementary. So since they're supplementary, we need to add these two angles together. So 100 plus 7x plus 17, and set them equal to 180. The left side, you can combine 117, so that gives you 7x plus 117 equals 180. Subtract 117 from both sides, and you get 7x is equal to 63. Divide both sides by 7, and you get x equals 9. And finally, number 20. Number 20, we're dealing with angles again, and we have angle N and angle L. And are these opposite angles or are they consecutive angles? Well, as we can see, N and L are not connected by any sides. They are directly opposite from one another, so that means they are congruent. So we set 6x minus 5 equal to 5x plus 5. We need to get the x's on one side, so we subtract 5x from both sides, and we get x minus 5 is equal to 5. Add 5 to both sides, and you get that x is equal to 10. And that's going to do it for this video, guys. I hope this video has been helpful. I hope you've attempted the problems and checked them and completed the attendance check for today. We will continue on with this in our next few lessons, and we'll go into more detail about it. This was just something that had to be thrown together to make sure we covered something today. Okay, so if you need any help, please make sure that you email myself or Mr. Thompson. And you know, we hold Zoom sessions at 2:30 every day, except for myself on Wednesday. He holds them on Wednesday as well. So if you're struggling with something, please contact us, let us know. Okay, thanks guys, and I will see you in the next video.